So to make the water, yeah, so let's say that you have this water, right? So we can, so let's say this is one layer, this is four. So let's say this is one, this is two, and let's say this is three. Okay. So what we do is that we have, we are here. We are in the boat, right? And you are emitting a sound signal. So you just send some signal right in here and you get back the signal. Okay. So let's say that something is there. So it emits, so this signal falls on this thing and it sends back the signal, right? So you know these, you know the speed of the signal, right? You know the speed of the signal, which is the speed of sound in water, right? You know the speed, right? And then you have some time measuring clock, right? What you do is that you measure how much time it took to go from here and then return back. Is that clear to you?
Yes, sir.
So you know the time, which is, let's say this is 2t. Why I'm writing 2t? Because, or let's say that you know this is t, not 2t. So let's say that this is t equals to, let's say 2t. Okay. So then what would be the distance? Distance would be how much?
Um, the speed.
Yeah, speed into time.
Time.
Right. Yeah, so you know the speed of the sound in water, this you know, right? And you also have calculated the time. So the signal goes here and comes back. So it has completed two distance, right? So this is you can write this as 2, or whatever you get, whatever distance you get, so you divide it by, so the actual distance would be whatever distance you get divided by 2, right? So let's say that speed of sound is 3, I don't know, 3 or 5 something, 337. This is in the air, right? So you, yeah, you find what is the speed of sound in water, and then you have this clock. So you calculate the time, and then you can calculate the distance of the, how much this is in depth. So is this what is the project is about?
Yes, sir.
Yeah.
They just told us to make a normal model of it.
How to, what, how to?
Like the model.
Yeah. Yeah. So you can, yeah, you can make it like this. Okay.
Yes, sir.
Because, yeah.
No, sir, you can tell.
Yeah. So, and let's say that there is some, yeah, there are some fishes which are, right, swimming, right? So you can also calculate, and let's say you can also calculate the depth of this object, right? So let's say this is the depth of this object, right? This is the bottom.
So they
So
told us to make a circuit of it. They didn't exactly tell us to calculate anything.
oh, just make the model.
Yes, sir. No, like the circuit when you when it's on and off, that one.
On and off.
Sir, I'll send a pic. Mummy.
Yeah, you send me those and we will figure out that what we can do. Okay. Yeah, you send me all those.
Sir,
So
I'll send it to the
learning, Learnivio
Learnivio.
team. Yeah, you send it to the Learnivio team, and then they will send it to me. Okay.
Yes, sir.
Yeah. So did you understood about this working model?
Yes, sir.
Just we have to send the signal and wait whenever it comes back. So this is the working model of sonar also, right? Whenever you have, so this is used in naval forces. So in Navy, they use this kind of model. So you see that in your sea level, there are some torpedoes which are set up. Okay. So to find those torpedoes in the sea, what the sailor or what the naval forces do is that they send some signal. So let's say that this is some torpedoes, right? So they send some signal and they receive back the signal. So then they can calculate the position of that torpedo. Okay. So this is called sonar. So this is called sound navigation and ranging. So this you have heard, right? Have you heard about this sonar?
Yes, sir.
Yeah, so I was talking about that. Okay, so we are already 15 minutes late, and what you do is that send me those projects. Okay, and then we will figure out what we should choose, which is the easier one and what we should choose. Okay.
Yes. Uh, Sir, yeah. For the concave mirror, I have to do a bigger than normal size. So it should be like twice. It should be big, and I have to choose between the water level indicator or the laser security alarm.
Okay, so in the water level and laser security alarm, you have to choose, and then you have to make this concave mirror. So concave mirror is
That's
easy,
compulsory.
compulsory. Oh, that one is easy. Concave mirror is easy, right?
Yes, sir. I
Yeah.
don't know
So
what.
we have to show the, yeah.
Yes, sir.
In concave mirror, what we need to do? We show the image formation or what?
So working model of concave mirror.
Okay, working model of concave mirror.
In project on general theory of relativity, so
Yeah,
like is how many pages should it be? Like 15 to 20?
15 to 20 is more than enough. 5 to
Okay.
10 is 5 to 10 is enough.
Okay, sir.
Yeah, 15 to 20 is because what you will write.
So 5 to
Generally,
10 back and front or just one?
yeah, only one side.
Okay, okay, sir.
Yeah. So first you write about general relativity, right? And then you talk about. So you only talk about the history, right? And
Yes.
yeah, you only talk about the history because theoretical part is very complicated. Right. So how general relativity is useful? So yeah, you have this Newton's law, right? So Newton's law is classical law, and then when you go beyond Newton's law, so in Newton's law you heard about Kepler's law of orbits and Newton's gravitation law and all, right? So when you go beyond Newton's law, then comes the general relativity. So yeah, okay. What should you do? They are not here. So yeah, so What happened? Why it is not right? Okay. Yeah. So we should wait a couple of more, but because it's already 2020, we are already 20 minutes late, right?
Yes, sir.
Yeah. So, okay. Let me start and let's see if they join. Mm. Okay. So we have done whatever we have done. So we have done vector part, right? So now we know vector and we know calculus also. So these two things we know, and these two will be helpful in all the rest of the chapters. So in this is motion in one day is the third chapter, right?
Yes, sir.
So third chapter in NCRT. So this will be helpful in third, fourth, fifth, and so on. So all these chapters they contain these vectors and calculus part. Okay, so first let us understand about motion. And then there is this rest. So how do we define a rest body, rest object?
When an object does not move, or when it's in inertia state.
Yeah, inertia is inertia will come in the Newton's laws of motion chapter. So Newton's laws of motion is this is third, fourth, fifth chapter, I guess. So inertia will come in fifth chapter. First thing is that how do we define rest and motion of a body? So this is defined by some frame of reference. Okay, so this is by choice that we take, right? Frame of reference is by choice that we take. And from this frame of reference, we define the rest and motion of a body. So frame of reference, it is needed to define the state of the body of an object or the body. This is the frame of the reference. Okay, so let's say that I am walking, right? So if I define my walking, so how will I define that? So I have to define some frame of reference to define whether I am moving or not, right? Let's say that I am in a car. Okay, so I am in a car and the car is moving. So if I am in a car and I am not contacted by the system which is outside of my car, okay, I am not contacted by the people that are outside of the car. So the person that is sitting behind will see me moving or in rest,
In rest, sir.
right? So the person who is sitting beside me is the frame of reference. Okay. So according to that person, only according to that person, I am in rest. And let's say that a person is watching me outside from the car. Okay. So for that person, I will be moving or I will be stationary.
Moving, sir.
Yeah. Yes.
Moving, sir. You'll be in motion.
Yeah, I will be in motion. So you see that the person which is outside that car, that is my frame of reference. Okay, so I can choose any of the frame of reference, and on the basis of that, I can define the state of the object. Is that clear?
Yes, sir.
Yeah. So stationary or rest? So if the object is not changing its position with respect to time and frame of reference. Then then the object would be called at rest. So if a person is changing its position, right? If a person is changing its position with respect to time and frame of reference also, so then the object would be called, then that object would be called at rest, because it is not changing its position. Is that clear, Rishita?
Yes, sir.
Yeah, and the motion would be vice versa. So if the object is changing its position with respect to time and frame of reference. Then that object would be called in motion. Okay, so we can see the example of a train and whatever stone is outside. So so some stone is grounded at the beside the railway line of the beside the railway lines, right? So you have seen, to mark the distance, some stones are embedded in the ground, right?
Yes, sir.
Or you can take the example of trees also. So let's say that you are in a train, right? And train is moving. So when you look outside the train and when you look at those trees, so you will find that those trees are moving or at rest.
Moving, sir.
Yeah, you will see that the trees are going behind, and you will see that you are at rest, right? You will see that you are not moving, but trees are moving, right?
Yes, sir.
And the person outside that train will see you that you are moving and the trees is at rest, right?
Yes, sir.
So you see that there could be two things. The same thing, the same object is appearing to be at rest, or the same object is appearing to be in motion, right?
Yes, sir.
So that is all dependent upon what?
Frame of reference.
Frame of reference, right? So the idea of rest and motion is absolute or relative?
Relative, sir.
Relative, right? So yeah, please. So did you write these things? Did you write these things?
Yes, sir.
Yeah. So let me write it here. So note the definition of rest and motion is not absolute, it is relative. Is that clear?
Yes, sir.
Okay. Now let us understand about this motion in 1D. Okay. So motion in 1D. So when the position of the object is dependent upon only, so let's say that how many coordinates do you have? So you have 3 coordinates, right? X, Y, and Z, right?
Yes, sir.
So this is the XY plane, right? This plane is the XY plane, and this plane is, this is which plane?
Z biplane.
YZ plane, right? So
YZ plane.
this is YZ plane. So you can see that in 3 dimension, this is your walls, right? So let's say that this is the corner of the wall. This is the corner, right? And let's say that you have this wall and this wall. So this will, and this is the base. So let's say that this is the base. This is the base. Okay. So let's say this is this is one direction, right? Which is the length of the floor, and this is the breadth of the floor, and this is the height, right? So you have your room, right? And when you look at the corner, so at the corner you will find the floor, and then you have 2 walls, right? And then you have this roof of your room. Is that clear?
Yes, sir.
So in the bottom part of your floor, the floor is how many dimension do you represent the floor?
3 dimensions.
No, floor is
Oh, floor.
yeah, floor is how many dimension?
Just 1 dimension.
Floor,
2 dimension.
2
2
dimension,
dimension.
right? Because we have the length of the floor, and then you
The
have the
breadth.
breadth of the, so you have
Yes.
2 dimension, right? And then you have this height. So height is represented by this Z axis. So in this way, this is Z and this is Y. So when you consider your room, so this is X and Y, and then you have this Z axis. Okay, so this was about the dimension. So when a body moves in, let's say, only in this direction, right? Or let's say a body is moving in the upward direction. So in the upward direction only. Or let's say a body is moving in this direction only. So how many coordinates do we need to represent all these motion? Yes.
So can you repeat it?
Yeah. So let's say that a body. So you have some floor, right? And on the corner, the ends are moving, right? So on the corner, ends are moving in one direction, right? So let's say they are moving in the breadth or at the what is the length at the length of the corner. So how many coordinate you will need to represent the motion of those ends?
One, sir.
One, right? Because you only need x coordinate to represent the length of the flow. Is that clear?
Yes, sir.
So the ends are moving. The ends are moving in this way only. Or let's say that ends are climbing this wall. So this is z-axis. So whenever height is involved, so let's assume that that is z-axis. Okay. So this is so when the ends are moving in this direction, so you only need one coordinate, and this and in this way also. So whenever you need when the position is represented by one coordinate only. Right. So that motion is called motion in 1D. Right. So is that clear, Rishita?
Yes, sir.
Okay. And what would be the motion in 2D? So when we require how many coordinates?
Just one coordinate.
No, 2D for 2D.
Two coordinates.
Two coordinates, right? So when we require, and I'm talking about a straight line only. So when the position is represented by two coordinates, then the motion is called 2D, motion in 2D. Right. So what would be the example of motion in 2D? So let's, yeah.
So when a ball is rolling across the floor.
Yeah, a ball is rolling. So the ball is here, right? There is a ball and it is rolling in here and in there, right? So this is in this floor, right? Or let's say that some lizard is moving on the wall. So some, how do we make the, so this lizard is crawling on the walls, right? So then you will require the X and Y coordinate to define the position of this lizard, right?
Yes, sir.
And the example of this ball also. So this will represent the motion in 2D. Understood?
Yes, sir.
Okay. And you have already learned about the vectors. So let's say that if I write my position like 3J. So this is motion in 1D or 2D?
1D.
1D, right? Because this is represented by, okay, so 3 and T I should write, right? So yeah, because this is, if I write 3J only, if I write 3J only, so this is a constant motion, right? This is
Yeah.
not changing with time. So to define the motion, we should write that it is changing with time. So this would be 3TG, right? So this is changing with time. Is that clear?
Yes, sir.
Yeah. So, and if I write R as 3 Ti plus 4T square G. So this is what? 1D or 2D?
2D, sir.
2D. This is motion in 2D, right? Because the object is changing with time and we require two coordinates, right?
Yes, sir.
Okay. So this was about the motion in 1D and 2D. And then you can also define the motion in 3D. So in 3D, how many coordinate system we will need?
3
Yeah,
coordinate system.
3 coordinate, X, Y, Z, all right. Okay, so yeah, and the next topic is physical quantities related with motion of a body. Right. So what are the physical quantities that are associated with the moving body? One is the distance. And then you have this displacement. Then you have speed, velocity, and acceleration. So these are the physical quantities which are associated with the motion of a body. Understood?
Yes, sir.
So in this chapter, we will learn about all these things one by one. So first, let us understand about distance. So distance is a scalar quantity. Right. Its SI unit is meter. Okay. And the definition of distance is what? So this is the total path length covered. Okay. So this is the total path length covered. And this cannot be negative. Okay. Is that,
Yes, sir.
yeah. So let's say that the object is, this is A, object was at A, and it moved from A to B. So this length is, let's say, 5 kilometers. Okay. And let's say that I move in the, let's say this is B, and then again I move up to this point C, which is, let's say, 10 kilometers. And then I come back. So then I come back, let's say 4 kilometers. Okay. So my path length would be how much?
19 kilometer.
19 kilometers. So let's say this is some point D. So my path length AD would be, this is a total path length. Total path length would be AB plus BC and plus CD. So as you said, 5 plus 10 plus 4. So that would be 19 kilometers. Right.
Yes, sir.
So this is the distance of an object. Is that clear?
Yes, sir. 1 second.
Yeah, please note it down.
I completed, sir.
Okay. And then you have this second physical quantity, which is called the displacement. So this displacement, it is a vector quantity. Okay. And its SI unit is also same. Meter. And the definition is what? So this is the shortest path between the initial and final position. Is that clear?
Yes, sir.
Yeah. So let's say that I have the same diagram. So let's say that I move to A to B, right? So this is 5 kilometers, right? And then I move to B to C. So this is 10 kilometers. And then I come back. So I move 4 kilometers. Okay. So my initial and final position are what?
Initial will be A,
Yeah. And final is D, right?
D. Yes, sir.
So AD would be how much? This would be
11,
simply 1.
11
11,
kilometers.
11, right? Because this is 5 and this is how much? So this is 10 and minus 4, so 6. This is 6. So 5 plus 6, which is 11. Right. So this is only the magnitude, right? Because this is a vector quantity, there would also be a direction, but we are only calculating the magnitude. Okay. Is that clear about distance and displacement?
Yes, sir.
Yeah. So let's say that, did you note it down?
Yes, sir.
Yeah. So now let us draw more pictures to understand the difference between the distance and displacement. Okay. So let's say that this is some point A, and this is point B. So let's say that I move this way, and I move this way, and let's say that I move this way. So let's say this is path 1, this is path 2, and this is path 3. So for 1, 2, and 3, my distance would be different. right?
Yes, sir.
But displacement would be only be A to B, which is path 1, right?
Yes, sir.
So this is the difference between the distance and displacement. That first difference is what? So this is
Distance can be negative.
yeah, displacement. Yeah,
Displacement can be negative, but displacement can only be positive.
yeah,
Distance can only be positive.
yeah. So first is that it's a scalar quantity, right? And second, this is that it's a vector quantity. Second difference is what? This is total path length, right? We are only writing the total path length, and this is shortest path, right? Third difference is what? As you said, it cannot be negative, right? And it can be negative. Okay. So these are the three difference between distance and displacement, right? And this is the relation which is important, that distance would be always greater than equal to displacement. Right?
Yes, sir.
Yeah, so this was all about the definition of distance and displacement. So let us do two questions based on this. And then we'll talk about the speed, and then in speed, we'll talk about the normal speed, then average speed, and then instantaneous speed. So, but let us do some question. So let's say that the body is moving in some circular direction. Okay, so the body is moving in some circular direction, and we have these so let's say that this is point A, this is point B, this is point C, this is point D, and let's say that this is some point E. Okay, so we have to find distance and displacement, and only the magnitude. Find distance and displacement first from A to B. Okay, we have to find the distance between A to B, where we know that this distance is, let's say, 10 meters. Okay. And in the second question, we need to find from A to C. And then in the third question, we need to find from A to D. And in the last part, we need to find out what is the difference. So from A to E. Okay. So is this clear to you?
Yes, sir.
A body starts from A, right? A body starts from A and it is moving in circular motion. So it is moving in this circle. And we have to find the distance from A to B, displacement from A to B, and then distance from A to C and displacement from A to C, distance from A to D and displacement from A to D. And then last part is A to E, where this angle is 60 degrees. Okay. So now let us come to this first question. From A to B. So from A to B, what would be the distance?
AEB.
Yeah, the distance would be arc length AB, right? So how do we represent this arc length? So this is represented by this way, right? So the distance would be this, right? Is that clear, Rishita?
Yes, sir.
So in your 10th class, you learned that what is the arc length? Yes, what is the arc length? Do you remember?
Oh, sir, L by 3/6.
Yeah,
L
so
2 pi
theta,
into L by 360. No.
theta by 360 into 2 pi r. So do you remember now?
Yes, sir.
Yeah. So from A to B, what is the angle?
90 degree.
90 degrees. So this theta is 90 degree and R we know. So AB would be 90 by 360 into 2 pi R is, let's write this 10 as 7 to make our calculation easier, right? So 7. Is that okay?
Yes, sir.
Or yeah, so this is 7. Okay, so this is 4 and this is 2. And then we have 22 by 7 into 7 by 2. So this is 11 and 7 cancels. So we have 11 meters. So this is the distance, right? And
Yes.
to calculate the displacement, so what would be the displacement?
So the line AB.
Line. Absolutely correct. So this would be the line. Right. So is that clear?
Yes, sir.
So Rishita, you tell me how we will calculate this line AB.
So Pythagoras theorem.
Absolutely correct. Yes, Pythagoras theorem. So displacement, which is AB, and we will use the Pythagoras theorem. So this is 7, this is 7, so this would be 7 root 2, right?
Yes, sir.
Yeah, I have directly written this, right? So this would be uh, root of 7 square plus 7 square, which is 2 into 7 square, which is
Yes.
7 root 2. So this is
9.
7. So this is the distance and displacement, right? For the A from A to B. Now, so please note it down. Then we will calculate the next one. Whenever you have noted it down, so I erase this part. So you just draw the diagram here. Yes, noted.
Yes, sir.
Okay. Yeah, one moment, Rishita. One moment. Okay. So the next part is from A to C. So just quickly tell me that from A to C, what would be the distance?
Sir, the arc of AC.
Yeah, arc of AC, and this is some semicircle, right?
Yes, sir. And displacement would be 14 meter, the
Yeah,
diameter of the circle.
yeah. So displacement would be AC, which is 2 into 7, which is 14. Okay, and this would be the arc AC, which is a semicircle. So we know that what is the total perimeter or circumference of circle?
Half pi
Yeah,
r.
2 pi r. So this would be 2 pi r by 2, right? So as you said, pi r, which is 22 by 7 into this is what? 7, right? So 7 cancels, and we have 22 meter, right?
Yes, sir.
And we can also use this formula also, right? So to use this formula, theta is how much?
Theta is 180.
180. So 180 by 360 into 2 pi r. So this is 2. So 2 pi r by 2, which is pi r. So we can use this formula also, or we can direct use the analogy of semicircle, whichever way you want to. Yeah. So I will erase this part, and the third question. So for the third question, what would be distance?
So arc AD.
AD.
Will it be the same 7 root 2? Sorry, not 7 root 2, 11.
No, we are calculating A, B, C, D. This R, not this R,
Oh, okay.
because we are moving in this way, right?
Yes, sir.
So this has come from this point. So from A to C, A to D, this distance would be A, and let me write it as A, B, C, D arc. So this would be theta, which is how much? This is how much?
240.
Yeah, 270, right?
270, yes.
So 270 by 360 and then 2 pi r. So this is how much? 9 and 12 and this is 3 and this is 4. So 3 into 2 into 22 into r is 7 by 4 into 7, right? So this 2 cancels, this 2 makes it 11, this 7 cancels, and we have 33 meters, right?
Yes, sir.
And as you said, the displacement would be the same as A to B.
7 root 2.
So yeah, displacement, this is distance, and displacement would be AD, which is 7. So please note it down. Did you note down this part, second part? Yes, Rishita, did you note down this part?
Yes, sir.
Okay. So please note down this third part and then we will do this fourth question. So for the fourth question, let me erase this part. Okay, whenever you have noted it down, please tell me.
Sir, I completed.
Okay. So let us do this last part, which is from A to E. Okay. So you know that this angle is 60 degree. And so what would be the arc AE?
60 degree.
Yeah,
Sorry, 60 by 360 into 2 into 22 by 7 into 7.
Yeah, yeah. So this would be 1 by 6 into 2 into 2 pi and r. So this 7 cancels this 3. And so this is 22 by 3. Right. And for the displacement. So for the displacement AE length, we have to find out AE length. So can you tell me how can we solve this question?
So the sector formula where we minus the
Yeah.
triangle from the sector and then we get the area.
So in sector formula, you calculate the area of the sector, right?
Yes, sir.
But we need to find only this AE length.
Oh.
Yeah. So first, let us figure out what is this triangle AOE. So this is 60 degree.
I
And
saw
yeah, this would be, let's say this is X. So this would be how much?
60 degree.
No, this is
X,
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 right?
yes, sir.
Because this is equal to this. This is 7. So this is equal to, the opposite to this is this, and opposite to this is this. So as you said, this is an equilateral triangle. First,
Equilateral.
okay. So first, let us try to figure out what is this x angle. So 60 plus x would be 180. So 2x is 120, right? So x is 60, right? So
Yes.
which means that this angle is how much? This angle is 60 and this angle is 60. So what is this triangle?
Equilateral triangle.
So if this is an equilateral triangle, then what would be A?
That's 7 meter.
7. So without doing the calculation, we can figure out what would be this displacement. So this is just from the analogy of geometry. Okay, so please note it down, and then we will do one more question, and the speed and average speed and instantaneous speed I will talk about in the next class.
Yes, sir.
So Afaf didn't come, and Akib also didn't come. So whenever you have noted it down, please tell me. Then we can go ahead.
Sir, I'm done.
Done. Okay,
Yes, sir.
so let's do this problem. We have so we have, let's say we have this 3 coordinates, right? X, Y, and Z. So a body starts from this point, and in the XY plane, it makes a semicircle. So it covers, and the radius of this semicircle is A. Okay, so it covers this much distance. Is that clear?
Yes, sir.
And then it goes A units in Z direction. A units in Z direction, A meter. And then it goes to A unit in Y direction. So this is 2A. Okay, so did you understand this part?
Yes, sir.
Yeah, so a body covers, let's say it starts from O, right? And then make a circle and reach there at point A. And then it goes A units in Z direction, which is B, and then it comes to this C point. Okay. So this would be the, so this is the motion of an object. So you can see that this motion is not in 1D, right?
No, sir.
Right. Because this is 2D, then this is 1D, and then this is 1D. So all the coordinates are involved. Okay, then we have to find out what? So question is that we have to find distance and displacement. Okay, so first let us find out what is the distance. So we have this path, right? So the distance would be OA arc plus this AB length, right? And then plus this BC length. Is that clear, Rishita?
Yes, sir.
So this OA arc is this semicircle, right? So the length of the semicircle is simply pi into A, right?
Yes, sir.
And AB length is A, and BC length is how much?
2A.
2A. So this would be simply pi A plus 3A. So this is A, we can take common, so 3 plus 5 meters. So this is the distance. Is this part clear?
Yes, sir.
And now we have to calculate the displacement. So displacement is a vector quantity, so let us write as R. Okay. So you tell me that this is the direction that I have moved. Right. So OA would be what? This is A. This is A. So OA is in which direction?
X, positive X direction.
Yeah. So what vector will represent my direction?
I
I
cap.
hat. I cap. And what is the magnitude or what is the X component?
A.
Okay. So let me write it as OA vector first and then AB vector and then BC vector. So OA is 2A I hat, right? Because this is A, so 2A, right?
Yes, sir.
And direction is I hat. What about AB? Yes, AB would be how much?
So AB would be
Yeah,
A.
A in Z direction. So yes,
A Y cap. A Z cap.
Z cap, and Z direction is represented by
K.
K hat. So AK, right? And BC is how much?
A 2A Y cap.
Why?
Sorry, J cap.
J cap. So the vector would be 2A I hat plus 2A J hat and plus A K hat. Right. So this would be the displacement vector. Right. So
Yes, sir.
what would be the magnitude? Let's see that. Do you remember the
Root of
yes,
2A
no, you do.
square
Yes.
plus 2A square plus A square.
Very well. So yes, absolutely right. So this would be oh, what is that? So this would be 4A square plus 4A square plus A square, which is 9, right? 9A square, so 3A. So this is the magnitude of this displacement. And if someone wants us to calculate the direction, right? So then we need to calculate what?
So the cross product
This one.
R cap.
Right. This represents the direction, right?
Yes, sir.
So then we need to calculate R vector divided by R magnitude. Okay, so you please, do you have any doubt in this question?
No, sir.
Yeah, please note it down, and then we will talk about the speed and okay, water level indicator electronic circuit. Hmm. Okay, so this is hmm. Yeah, whenever you have noted it down, so please tell me. So you have to make these circuits. Oh, God. Yes, Rishita, you have sent me your project work, right?
Yes, sir.
Yeah, so I'm seeing that the laser part is difficult. This water level indicator electronic circuit. Okay, what is the use of this electronic circuit? Because you see that you have seen the let's say some mugs, jugs, or let's say that you have some transparent bottle. So in that transparent bottle, or let's say you have water purifier, right? So in the water
Yes.
purifier, you have that transparent part, and the bars are there, right?
Yes, sir.
So you can check from the bars that how much is water in there. So you have the units, right? You have this volume, that this is 5 liter, this is 1 liter, this is 0.5 liter, and so on. And then you can see the water level, because that part is transparent. So that is just like this diagram that you have, right? So you have some horizontal bars, right?
Yes, sir.
So this will, but how this is related with this electronic circuit? I guess that if we switch on the light, then up to which level the water is, so that light will indicate only, right?
Yes, sir.
Right.
Yeah.
So we need to see how this is, how this works. So we need to find out. Okay, I will check that out. So did
Yes.
you, yeah, did you note it down?
Yes, sir.
Okay, so now let us go ahead, and the next topic is why this is frozen. Okay. Yeah, the next topic is speed. So this is also, this is a scalar quantity. Okay, and its SI unit is, what would be the SI unit? So its SI unit is meter per second,
Meter per second.
right? And the definition is that it is the rate of change of distance, right? So speed is x by t, rate of change of distance by time. Okay, is that clear?
Yes, sir.
Yeah, so there are three definitions, or so three types of speed. So that is dependent upon the motion of the body. So let's say that if you have, so I will talk about this in the next class. If you have uniform motion, and the second type is that if you have non-uniform motion. So in this part, the speed is simply x by t, right? And in the case of non-uniform, this has also two kinds. So one is this average speed, and the other one is this instantaneous speed. So this I will talk about. So the average speed is delta x by delta time, right? Total, and then you have this instantaneous speed. So let's say this is s instant. So this is dx by dt. So I will talk about all these diagrammatic representation in the next class. Okay, because rest of the people would be there. So then, right, because we should not go ahead, right?
Yes, sir.
And I will also check what is this water level indicator, electronic, because we already know about the water level indicators, right?
Yes, sir.
Yeah, you have seen the water coolers, right? So in the water coolers, you have these bars that represents the, and on the bars, you will see the numberings. So